Hello guys, welcome back to the Quantities surveying workshop, and in today's video we are going to be treating how to measure the rafter and the king post in a hip roof. Like I said before, there are different types of rafters. There is the principal or hip rafter, the common rafter, jack rafter, and sometimes the valley rafters. In the plan we are using, there are no valley rafters because this is a typical simple hip roof. So when there are bends and recesses, that is when you see valley rafters in the roof. So when calculating for your rafters, your struts, you have to have some knowledges in your arsenal, and that knowledge is the knowledge of trigonometry. So you need to be conversant with trigonometry, Pythagoras theorem, trigonometric rules and angles, like corresponding angles, alternate angles and stuff like that, angles at a point, angles in a straight line and stuff like that. So you need to be conversant with those rules. So now in this video we are going to be starting with the measurements for the common rafters. So if you look at this plan, where are the common rafters? The common rafter is the rafter that is here, that's dividing the hip triangle into two. This rafter here and the rafters that are along the ridge board. So if this is your ridge board, the rafters spanning like this on the two sides are what? Your common rafters. We have to be measuring for them. Now, how do we measure for what? Our common rafters. Now, all you need to do is this. Go to the hip side of the roof. This is the hip side of the roof. Locate the triangle. So, if you can see this, this is a triangle. That's the hip triangle. So, what you need to do is you should remove the hip triangle and divide it into two to form a what? Right angle triangle. And that is what I have done here. So, since we know that the span of the hip side of our roof is 11,925, all you need to do now is to divide it by what? 2. And dividing it by 2, we got what? 5,962.5. So, X would be our what? Common rafter. Y would be our what? Hip rafter. Because like I said, this is the common rafter, and these two sides are what? Our hip rafters. So if you can find X, we found our common rafter. If we can find Y, we found our what? Hip rafter. So since we have one parameter, we have our angle, which is the pitch angle of the roof, which is 30 degrees. All we need to do now is to use a rule called what? The trigonometric rule, which is SOHCAHTOA, sine, cos, and what? Tangent. So as you all know, the formula for sine is what? Opposite over hypotenuse. Cos is what? Adjacent over hypotenuse. And tan is what? Opposite over what? Adjacent. So now how do we find our X, which is what? The common rafters? All you need to do now is this. Start from the known points to get the unknown points. So now we know that we have this part, which is our adjacent. The adjacent part of the triangle is what? 5,962.5. So we're looking for what? X. So since we don't know our opposite, but we have our adjacent, we are going to be using what? Tan. That's 2. Tangent is equal to what? Opposite over what? Adjacent. We don't know our opposite. We don't know our opposite, but we know our what? Adjacent. That is why I use what? Tan. So what you do is this. Tan 30 degrees is equal to what? Opposite over what? Adjacent. Tan 30 degrees is now equal to what? What is our opposite? X. That's what I did here. What is our adjacent? 5,962.5, and I brought it here. So when you cross multiply to find X, X is equal to what? Tan 30 times what? 5,962.5, and if you multiply that, it will give you what? 3,442.5 meters. So 3,442.5 is the span for our common rafter. So now that we've gotten the span, that's the length of our common rafter, we need to know how many common rafters are in this roof. So now, like I said before, the wood dividing our hip triangle into two is the common rafter. And how many hip sides do we have? We have two. That's one for this side and one for the other side. This is broken, so I didn't draw the other triangle. So we're going to be having two hip sides, that's here and here. So if we're going to be having two hip sides, it means that we're going to be having one common rafter at each side. So there'll be one common rafter here and another common rafter at the other hip side. That is making it what? 2. Now I also said that there will be common rafters along the ridge board. So now to find the number of common rafters along this ridge board, all you need to do is this: find the span of your ridge board and divide it by the spacing of your truss. Because you know that the common rafters here make up a truss. One common rafter here, the other common rafter here, and then the tie beam cutting across would make the truss. So in order to find for your common rafters along the ridge board, just go and look for what you've calculated as the number of trusses you have along your ridge board, or you can still do it again here by finding your ridge board and dividing it by the spaces of the trusses. So the number of common rafters now for the ridge board side, we know that our ridge board is we've calculated it as 2,100. We divide it by the spacing. It was stated in the specification that the spacing is 1,200. When we divide it, what we get? 1.75. That is approximately 2. Then we'll add 1, which is give us 3 number. So there are 3 number of trusses along the ridge board. So now, since we know that there are 3 numbers of trusses along the ridge board, all we are going to be doing is to multiply it by 2, because they will be on both sides. That's on this side and on the other side. So what we'll now do is this: we'll times what we have here, 3 times 2. So 2 times 3 will give us 6 number. So the number of common rafters along the ridge board will be 6. So now we have gotten for the ridge board. The next thing is to find for the number of common rafters along the hip side. And there are how many hips? Two hip sides, and I told you that one common rafter will be seen on each, which will make it 2. So if you add the amount of common rafters on the ridge board and that of the hip side, that is 6 plus 2 will give us 8. This is the total common rafters we have in the roof. Then we describe. The specification states that the type of wood we use is 50 by 150. So you write 50 by 150 mm sawn hardwood as common rafters. What did we get as our span? 3,442.5. We divide it by 1,000. That's 3.44. Multiplied by the number, which is 8. That is this. It will give us 27.52. When you multiply 8 times 3.44, it will give us this. Doing this, you measured for your common rafters. The next rafter we're going to be measuring would be the hip rafter. So we bring the same triangle back. So half of this is what we are going to be looking for. So since we know the parameter from here to here, and we know the parameter for our common rafter, all we need to find now is this, which is our y. So now that is what I have done here. Half of the span of the roof was this 5,962.5, and then the span of our common rafter is 3,442.5, and the hip rafter or the principal rafter is y. We need to find for y. So since we have 2 parameters, all we need to do now is to use Pythagoras theorem. So Pythagoras theorem, the formula is hypotenuse square is equal to the sum of the square of the 2 of the two other sides. So hypotenuse square is equal to what? Opposite square plus what? Adjacent square. So what is our hypotenuse? The hypotenuse is the longest part of the triangle, which is what? Y. I did this here. That's y square equals to what? Opposite. What is our opposite side? That's the common rafter side. 3,442.5. I brought it here and I squared it. Plus what? The adjacent, which is this side. 5,962.5, which is this. When you do all the arithmetic, you get this figure. Then what you need to do now is to remove the square from the y by square rooting both sides. So square will cancel square root at this side, and then it will be square root at this side. So the square root of this will be equal to what? This 6,884.93. That is the span of our what? Principal or hip rafters. So all you need to do now is to describe. In our specification, the wood used for our principal rafter is the same wood used for our common rafter. So all you need to do is to write ditto, which means that the same specification as written above, hip rafter. So our span is what? 6,884.93. Divide it by 1,000 to get it in meters. That's 6.88. Then you times it by the number of hip rafters you have. How many numbers of hip rafters now will we have in the roof? You go to the hip side. How many hip sides do we have? 2 hip sides. How many rafters per hip side? That's 2. 1 here, 1 here. There will be another 1 here and another 1 here. So that's making it what? 4. And that is why I multiply this by what? 4. Doing this, you've measured for your what? Principal or hip rafters. Then the next one we're going to be measuring for are what? Your jack rafters. Now this is where there's a little work. What are your jack rafters? Your jack rafters are the rafters lining along what? The hip rafters. So the rafters coming like this are what? Your jack rafters. And you know that the jack rafters are not the same length. So the jack rafter here is different from the length of the jack rafter here, and is different from the length of the jack rafter here, because what? The rafter is what? Sloping. So we need to find for each of the length of that jack rafter. So that is what I have done here. I have brought that hip triangle outside. We know that the span from here to here is what? The length of our common rafter. The span from here to here is the length of our hip rafter, and the span from here to here is half the length of what? The hip side of the roof. So now we know that this is what? 5,962.5. That's half the length of the hip side of the roof. Then it is stated that in our specification that the rafters are spaced 1,200 center to center. So it means that the spacing for each rafters is 1,200. So from the common rafter to this place, making it A, is 1,200. Then from there to the next 1,200, we'll make the second jack rafter, and then continuous. So all we need to do now to find the jack rafter for A, which is this span here, we need to cut out that part of the triangle. So this part of the triangle like this, I have brought it out. So the length of the jack rafter for A, that is this side here, A, which is this A, we don't know what is the distance from here to here. We don't know what is the distance from here to here, but we know that our angle here is what? 30 degrees. So all we need to do now is to use SOHCAHTOA, which is sine, cos, and what? Tangent. We know the adjacent side. We are looking for what? The opposite side. So we're going to be using what? TOA, tangent. So now we write TOA, which is tan 30 degrees, is equal to what? Opposite over what? Adjacent. So tan 30 degrees is equal to what? A all over what? 4,762.5. How did I get 4,762.5? you remember that we cut this this triangle from the A side. So since you know it is 1200 centers, we need to find what's the distance from here to this end. So all you need to do now is, since we know that it is 1200 center to center spacing, and we know that the span for this side is 5962.5, all we need to do now is to minus 1200 from 5962.5. That will give us the span from here to this end, which is what, 4762.5. So since we know how we got our adjacent, we will now cross multiply. So to find A will now be equal to what? Tan 30. To find A will now be equal to what? Tan 30 times what? 4762.5, which will give us 2749.63 meters. So this is the span of the jack rafter for A. So we do the same thing for B. To find B, we'll cut out that portion of the triangle. So when we cut out the portion of the triangle, we need to find what's the span from here to here. So how do we do that? We know that from here to here is 1200, then the next 1200 is giving what? 2400. So minus 2400 from the total span, it will give us the span from here to here. And that will give us what? 3562.5. So in order to find B, we will be using what? We'll be using tan is equal to what? Opposite over what? Adjacent. So tan 30 is equal to what? B all over what? 3562.5. Cross multiply. B is equal to what? Tan 30 degrees times what? 3562.5, which will give us what? 2056.81 meters. So the next one we're going to be doing is what? C. So you use the same process that I've done in A and B to do C. You find for the span. So we get our span as what? 2362.5. We're going to be using what? Tangent, which is tan is equal to opposite over what? Adjacent. So our opposite is C, our adjacent is what? 2362.5. Cross multiply. C is equal to what? Tan 30 times what? This, and it will give us what? 1363.99 meters. So you do the same thing for what? D, which is the last one. And if we minus the distance from here to here, which is 1200 times what? 1, 2, 3, 4 times 4, which will give us 4800. So it means that the distance from here to here is 4800. So if we minus 4800 from the total span, it will give us the distance from here to here. Which will be equals to what? 1162.5. So we do the same thing. Tan 30 degrees is equal to what? D all over what? 1162.5. D is equal to what? Tan 30 degrees times what? 1162.5. That's when you cross multiply. So D is equal to what? This 671.17. So you see that as we go from A to B to C, the length of the jack rafter keeps reducing. That is because what? The hip or principal rafter is slanting. That is the reason why these jack rafters keep reducing. So now, since we've gotten the length of all the jack rafters, now we need to know. All I did here was that I wrote the summary of everything that I have calculated. So this is the length for jack rafter A, jack rafter B, jack rafter C, and jack rafter D. So after doing this, we need to know the number of jack rafters that are in this roof. So if you look at this, I said that the jack rafters are lined along across the this thing, the hip or principal rafters. So if these are hip or principal rafter, it means that we're going to be having jack rafter A, B, C, and D lined around here. 1, 2, 3, 4. So since this is a right angle triangle and the right angle triangle are 2, that's here and here, what we have here will be the same thing as what we have at this side. So we're going to be having what 2 jack rafters of each length at this side. The same thing is what we're going to be having at this side. We're going to be having the same thing at the other side of the roof. So which is making it what 1, 2, 3, 4. So if you have 1, 2, 3, 4 at this side, then it means that we're going to be having the same thing at the other side, which is making it what 8. So it means that each length of the jack rafter, we're going to be needing 8 of them to make the roof. That is why I multiplied each of them by what 8. So jack rafter A, convert it to meters, which will give us what 2.74, multiplied by 8, which will give us this. The next one is B, 2.06 times 8 will give us this. C, 1.36 times 8 will give us this. D, 0.67 times 8 will give us what this. When you add everything together, this is the total quantity in meters of timber that you are going to be needing for your what jack rafter. So you do the same thing in your description. Ditto, the same size of jack rafter is the same size that we've been using for the other rafters. So you write ditto jack rafter and then you measure. So the last thing we're going to be looking for would be our king post, and there's no need for calculation in this part because our king post was already specified in the drawing, the section of the drawing. This member we have here, from here to this end, is the length of our king post, and it is given to us as what 3.50. So all you need to do now is to describe 50 by 150 mm sawn hardwood king post, length 3.50. You multiply it by what 3. Why are we multiplying this king post by 3? We're multiplying the king post by 3 because the king post are found on the trusses. And how many trusses do we have? We calculated our trusses to be what 3 in number. So, and what comprises of the trusses? The trusses comprises of what 2 rafters, a tie beam, and what 2 rafters, a tie beam, king posts, and struts. So since we are going to be having 3 trusses, it means that on each of that 3 trusses there will be what a king post. So doing this, you've measured for what your king post. So we've come to the end of today's video. Hope to derive adequate knowledge from this. Please don't forget to like, share, and subscribe to this channel to see more educational content on measurement. Thank you, and we'll see you in the next video.